Hello, Brian. This is Maudie Fadi. My program is called ND Manager. ND Manager is short for Network Device Manager. The purpose of ND Manager is to fetch information on multiple routers or multiple devices in a data center where we have different router vendor platforms. So you have a lot of routers that you want to interact with, and it's a mix of different vendors, and all these different vendors have different commands to interact with the devices. So ND Manager is the main program here of the project, although there is other modules that ND Manager works with to get information depending on what the user is looking for. Let's take a quick walk through the ND Manager script. So ND Manager over here, I have some doc strings that explains what ND Manager does and how to run the script. An example of a command line option here of how to run the script. Basically, just the options you have when running the script. So the function over here is using argpass to get to make it possible for the user to have options when running this program on the command line. I didn't mention this, but this program is only command line based. There is no GUI. You run your program on the command line, and you get most of your output on the screen. Some output actually goes and gets saved in a file. That is one function that does that, but most of the output is on the screen for you to see. So over here, if a user actually passed a file, we would go through that file and do what we need to do. Basically, what is happening here is that the file that the user is specifying, let's look at the file over here. The file, let's look at it. So the file that the user is specifying basically contains credentials of the devices that the user wants to connect to. So the user, once a user specifies that file, we will go through that file and try to connect to all the devices in that file. And of course, if anything fails for whatever reason, I'm trying to catch the different exceptions over here. These are exceptions that are possible when you run these commands, or when you try to actually connect to the devices. You might run into these exceptions. So I'm trying to catch them, and then at the end over here, let's just catch all kind of exception. Yeah. So another thing I'm doing here is that a device that is not reachable, if we hit an exception, that device is going to get appended in a list. That list I'll provide to the user at the end, telling them, hey, these devices, we couldn't connect to these devices. So else clause here is saying, okay, this device, I mean, the user did not specify the file option. So which means the user has to specify, as I put in the print statement here, the user has to provide all the connection parameters on the command line. So you either provide a file that has all the device information, or you just you just specify all the parameters of the device that you want to connect to on the command line. But this is just for a single device. So user provides all the connection details of this single device, and I just do the same. I go through and I try to create a device object, and if I try to make a connection by opening that socket and it fails, then I just throw error. So by the time we get over here, we don't really have any issues. So we've connected to one device, or at least multiple devices, and then we're actually checking the options that the user specified. So device info, or neighbors, or IP address, or optics, these are all different. This will all provide different things. I don't know if I need to describe what they will provide or not, but we would see when I run the command. So over here, I'm trying to do something where if a user specifies an optic name, okay, so the user says optics in the command line options. That means the user is trying to find an optic, and so the program would prompt the user for an optic name. If the user specifies an optic name that we don't really have in our inventory, I would print out that, hey, we don't really have that optic in our inventory. And I would actually allow the user to try again. But I'll also print out the optics that we support. I mean, the optics that we have in our inventory, so the user can know what optics to search for. If that optic is not in the inventory, then they know where we need to run the program because we don't really have that optic in stock. I am doing the same thing over here. So in this case, adjacent option means the user is supplying or is actually passing two different device models. To see if device A, if in the data center that is a model of a model A connected to a model B, pretty much. So that too, I'm making sure that if the user specifies a model number, that's a model number that actually exists in the data center. If not, I would say, hey, we don't have that. So these are the models that we have in the data center. So they can actually know what to specify. So the user is interacting with ND manager. So let's go through the actually doc strings and I can tell you what I'm doing here. So the doc strings, so I run Python ND manager specify F, which means file option. That means the user specifies a file name, which is devices2 CSV. And then the dash C means pass a command. And the command that they're passing here is adjacent. So adjacent tells me that this user is trying to find two devices that are adjacent to each other, which means they are connected to each other. And what that means is when I come over here and I'm seeing args.command equals adjacent, where is adjacent? Args.command is equals adjacent, then I would ask the user for the two different models that he wants to check if they're adjacent or not. Okay, so let's say user specifies one device model here and then specifies a second device model here. Then what I do is that I just put those in the parameters over here and call the adjacent router. So we can go to adjacent router. Adjacent router would just take the two models that the user is interested in and go through all the devices in the list in the file to see if there is a connection anywhere where this model is connected to, where model X is connected to model Y. That basically means you connect to one device and see what that model is, and then run a command on that device to see if it's connected to anything that is model Y. So model X is the device you're on, and model Y you're trying to see if there is a device connected to it. So I mean, I guess you could go through this. This eventually would print out if you have devices, if you have in the data center you have model X connected to model Y, it will print it out for you on the terminal. So fine, let's go through the other thing. So ND manager is your main program that the user interacts with, and then you go to device DB. Device DB, if the user specifies their command is device info, they just need some device specific basic device information, device IP address, device host name, device vendor type, and stuff like that. Device serial number. These are pretty basic, but very important information. They would run device information. So ND manager would call device DB, and device DB will provide that information. If they wanted neighbors, the devices that are connected to this device, again, ND manager would call device DB, and then device DB would find it, and then IP addresses connected to device, same thing over here. The other thing is if so here you're getting device information or you're getting neighbors or you're getting IP addresses depending on what the user specifies. And in here, find optic is very interesting in the sense that it's almost as interesting as adjacent router, which basically is trying to find two devices connected to each other in a data center. Find optic, the user specifies an optic that they want to find in the data center. So the ND manager basically asks the user for the optic name right here, enter the optic name right here, and then ND manager will call the find optic. And find optic would actually run specific commands for different vendors to get the list of optics that are installed on that router. So So I would say this project is not complete in the sense that there are certain things that can be improved. So in here, if you do show chassis hardware, there are certain information that are not really available. This is a Juniper device, and Juniper is sometimes if a hardware is installed that is not it's not a Juniper brand, they don't want to show you all the information. You actually have to go into the shell to actually dig that information out. So getting information from the shell is not really yeah, it's not fun for automation. So I don't really know how to do it here. But anyways, this function is interesting in the sense that you give it an object name and it will go through, depending on the vendor type, it will run a command and then find the optics for you. And if it finds the optics for you, this is actually a program that will not output the results on the terminal. It will actually save the output in a file for you. Um, so at the end of the day, there are a few functions here that would called printer.py. So printer.py, what it does is it basically just uh, it takes a parameter and then a dictionary or whatever you give it, and then it will print it nicely for you. So it will print it in a way that is readable. There is different functions that I would call printer.py, but this is a function that the user will interact with. In fact, the user only interacts with ND manager. Okay, so let's go through, and I do have doc strings for all of these to describe how to use them, even though the user doesn't really interact with anything but ND manager. But I do have doc strings for the other functions too, for the other modules. So let's run through a few things. So I would actually try every feature that I implemented. So the first feature that I would try is that, so Python ND manager -f means if I'm supplying a file, and this file devices2.csv. Let's look at that. So devices2.csv has three devices. I'm actually going to remove the third device because I put that there for testing. I'll add it later to see. So this device is not reachable. So I just put it there for testing. Eventually I'll add it so we can see what happens if an unreachable device is in our list. So let me remove it for now. So I'll call device info and see what we get. So device info. So device info is actually putting out, you selected the file option. Be sure you pass the file in the command line. Sure enough, I did pass a file name, right? And then it's telling me, whenever it successfully connects to a device, it will tell me, hey, you're connected to device. This is a Junix device. You're connected to that, it's an EOS device. And then it will print a device info for this host name, and then device info for this host name. And device info, like I said, pretty good, basic but pretty good information. The vendor type, the model, the serial number, the OS version, the host name, the FQDN, the uptime, and the list of interfaces. So this is for two devices, right? Device one and device two, and this is what we have in our device list. So I'm gonna run the same thing, but this time I'm gonna give it neighbor. So it goes through and finds each neighbor. So it goes through and finds all the neighbors for these devices. So this one is in a JSON format or hierarchical format. So it prints out. So for this device, so neighbors of this guy is that for on this interface, it has this neighbor. On this interface, it has this neighbor, and this is pretty nicely readable. So I didn't really, I formatted it just a little bit, but I think this is just good the way it is, because every interface should correspond to a neighbor, at least if the interface is up and functional. And the same thing for this guy. This guy has only two neighbors. On Ethernet 1.1, it has one neighbor. Management 1, it has one neighbor. So let's go through and run. So let's do, which one do we? So let's do optics. So I want to find some optics, and then the program comes and tells me, hey, what kind of optic do you want? I would say Hisense. I know we have Hisense on these devices, and then I enter. And then, so this is find optic is one of those that doesn't really output anything on the terminal. It will print out a file. Um, so the file in here is optics output, and it's appending, and it will actually put the time. So optics in my host, this is that optics in So it didn't really find any optics in it. So if you see the time 1958 right now is 1958. We can see over here 758 over here. So that's his latest file right here. So this would just append. It will keep appending this file. If you keep going up, you see I took this at 7:37. I took this at 11:43 in the morning. This one also 11:43 in the morning. So this find uptake is the one that doesn't really output on the terminal. It just appends on the optics output file. Okay, so I've done okay, I haven't done adjacent. So let's do adjacent. Let's try to find two device models that are adjacent to each other. So this program would come and tell me, hey, what enter the first model. I would say 7060 CX is my first model, and the second model is QFX 5200. I want to see if there is two devices, two models that are connected to each other in the data center. So it's telling me these are the queried models, and we'll go find out if we have any. And it so enough, it comes back and tells me, hey, this host here is a 7060CX, and it has a connection to this other host, which is a QFX52. And this is what I want. I want to find devices that one model is this, the other model is this. And sure enough, I have one of those connections, so I can just go and actually make a reservation for these devices and use them, or at least I know that these devices are available. So I think that actually covers the features that I was testing. Let me see. So we have device info enables optics. Oh, I didn't do IP address, but we did adjacent and optics. So let's do IP address. So IP address is IP add. IP add would go ahead and look for IP addresses on all the interfaces on these devices. So it'll come back and loop back 2. It's an IPv4 address and it has IP address. Ethernet 301 is an IPv4 and it has address. IPv6, there is no addresses installed for IPv6, so we are not seeing any IPv. But if there was IPv6, it will just be hierarchically installed in those braces right there. So those are all the features that I have. You have device information, you have neighbors, you have optics, you have IP address, you have adjacency, and like I said, that is built in. What's built in here is that if you actually, let's try this. Let's go ahead and say, let's try to find adjacency, but we're entering the wrong model. So let's say we do bum 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 bum. Let's do that. It says, hey, this guy is not a supported model. Supported models are, and it just tells you all the supported models on this in this data center, or at least this script knows about. But now if we enter a valid one, then sure enough it goes to ask for the second model. Second model, we make a mistake, and it comes up and tell, hey, this is not supported. But okay, I'm gonna enter the right one, and then it goes ahead and looks for whatever information I want. So you can also just use your keyboard to just get out of here if you want to just terminate the program. And this is not the only module that has. This is not the only one that has that. So optics also has the same feature, where it will prompt you for information if the information you entered is not correct. And also, so I did try to make sure that the errors that could possibly be thrown are captured here. So these errors. So this is where we come in, where I add a device that I know is not reachable. So I'll just grab one of these guys and just change the IP address. Let's just make this 75 or something. Let's make it something I know for sure is not available. Let's do 0 or something. I know this device is not available, so I will try to do device info, and let's see what we get. Let's do device. So I'm connected to two devices, and now it's trying to connect to the third device, but the third device is, I'm sure it's not available. So we get we get some errors, but it still continues. The program still continues to get us information we want. Device info for host 1, device info for host 2, right? No device info for host 3. However, at the bottom over here, we see note, these devices were unreachable, which is the one that has a 0. It tells me that this device is not reachable. So it doesn't crash. It gives me errors. And if you see over here, it says connection exception socket error during blah blah blah. So you can use that. And this is my custom message. Check IP address and credentials. And sure enough, I got this right, because if you check your IP address, if you check that this, you would see that this IP address is not right. So that is just coming from me saying, hey, check your IP address and your credentials if we have this connection exception. Other places I have, I mean, this is also the same thing. This is for the file option, and that one is for the single device option. Other places, I mean, I guess that's it about for this program. So one place I did not worry about the CSV caching CSV file errors is that CSV file errors are actually caught pretty nicely by Python by default. It's like 2 or 3 lines telling you that the file was not found. So I didn't really bother trying to catch it. So I wouldn't say this project is complete, but it's functional. It's doing what I wanted to do right now. That is more that I can add to this project. That is more I can add to this project. And I think in the very near future, I might be able to tell my boss that I've made the script and see if we can make it useful at work. But yeah, that's it for me. I'm trying to think of if there is anything else I need to add before I close this. So we've run through the programs, find uptake, adjacent router, and the printer function. So we have all of these guys. Yeah, so that's it for me. I hope that meets what you require. All right, thank you very much, Brian. Bye bye. Hey, Brian. So I forgot to test out the one device, the single device option, where you basically you provide all the information, all the credentials, user information on the command line. So this is when you don't specify a file. So what you do in the command line, you basically so I'm running Python ND manager, and then option I for IP address, U for username and password, and then you put the device, the vendor type, and then the device info, which is the command, which is the info that you're actually interested in, and then you run it, and it tells you over here you can see a single device option. Provide all connection parameters on the command line, and then it tells you it's connected to that single device that we just put information for, and then it prints out the information for that device. And we can do that for something else like uptake. We can do uptakes, and it will look for information for us. So here I want to say 100 gig AOC. We have some AOCs in that Juniper device. Let's see if it finds that, and then we can go to the output file. Like I said, so the find uptakes would print out in the file. So over here it's 7/26/2013. If you look at the time right now, it's 2013. So that's when this file was appended, and it basically just looked for this 100 gig AOCs, and it appended it for us in here. So it found the uptakes and it appended our uptakes file. So I just proved that the file option works, and also the single device option works too. Okay, that's what I wanted to add to the video. Thank you. Bye.